Thank you. Good afternoon from my side. I'm Iris. I will be hosting the panel on 3D printing tonight. And we will look at 3 different industries: bioprinting, food printing, and industrial manufacturing. And I try to keep some time at the end for questions, so please keep some questions in mind, or stay hungry, stay foolish. So a panel is nothing without the panelists, and I would like to introduce our first panelist, ladies first, Anna Kreuder from Cellbricks. Just give her a hand. Startup too, Berlin startup, specializing in printing mini organs.
Exactly. Thank you.
Next is Daniel Wilkens, the designer and founder of Message in a Cake, who uses 3D printing for producing cakes. Down. And last but not least, we come to the industrial manufacturing case with Joachim Zettler, the CEO of APWorks, a 100% subsidiary of Airbus Group, and who produces bionically optimized metal parts.
Geht das? Okay?
Yeah. In my careful preparation of this panel, I asked the panelists to bring some of their products, and they did that, because I really think that 3D printing, that's what 3D printing is about, to really have some data and then magically, in a matter of hours, have really an object in your hands, a tangible object. And I would like you to introduce yourselves and your products, and also tell us a bit why and how 3D printing enabled you what you do.
Yeah, Joachim Zettler, my name. Thanks for being here today. I'm the CEO of APWorks. We are a wholly owned subsidiary of Airbus in Munich, and we focus on industrial additive manufacturing. So why additive manufacturing? Actually, in the industrial world, you don't talk about 3D printing. That's more on the consumer side, but it's actually the same. So we try to bring this technology into regulated markets like aerospace, automotive, and medicine. And I mean, I brought with me some examples. I think we will see later on the Light Rider, the first 3D printed motorcycle. And you know, in the end, it's all about how can you use this technology to generate a kind of business case in a positive way, get rid of weight, focus on functional integration. And if you take this armrest, for example, you have this is a typical armrest. You machine it out of a solid material, aluminum. This is the printed version, 100 gram more lightweight. If you multiply it in an A320, for example, you can save yourself 30 kilogram nearly. And that's the interesting thing we focus on now for aerospace. What you see here is you can apply it to whatever scenario, and we will come to that in a minute, I would say, how we actually do that. So, happy to be here.
Daniel?
Yeah, my name is Daniel Wilkens. I'm an industrial designer. I studied industrial design in Essen, and yeah, for me as a designer, additive manufacturing or rapid prototyping is very familiar to me. I'm using it for creating design models. And I had a class at the university about 3D printing, and when you're so familiar with it, you're starting to explore unusual fields of 3D printing. And so I researched on 3D printed food. And yeah, first I was fascinated and some kind of irritated at the same time, because I saw some applications. There were people printing pizza, and why should I print a pizza? I can do that by hand. Now I understand maybe why people are printing pizza, because it's just basic work. If you have a new technology, you have the right to explore some things, and it's okay. But I decided to create my own food printing application, and I invented the world's first 3D printed cake. I'm using a 3D printer to arrange dough in a baking tin in a way that you have pictures inside the cake. So if you cut off the slices, you have individual motifs on every slice or piece you cut off. And so you can tell stories through the cake and the cake becomes a kind of communication medium. And this cake tells you what happens to you if you eat the whole cake at one time. So the matchstick man is growing in a way.
Yeah, can you eat it?
Yes, you can eat it basically, but you can't eat this one because I prepared it a few days ago and I drove it to Berlin by car for a few hours. And yeah, my simple prototype I'm using to print this, yeah, basically I can't assure food law conversion, so I'm not allowed to give it to you. But it tastes good.
Except of when I sign something that says like, okay, I know that I'm eating something I may have some problems afterwards with.
Pardon me?
No, it's okay. So you have to sign something, right? So
Yeah,
it's
right.
not like
If I sold it once, and then I call it a piece of art, and the people have to subscribe that I'm not guilty if they eat it and something happens. But it's all okay. I mean, I eat it every week and not nearly, yeah, sometimes every third day. And I mean, the machine is okay, but everything should be made from stainless steel, and that's not the case. I clean it every time I use it, and it's okay, you can eat it and you won't get sick, but I'm just not allowed to give it to people here.
Thanks. Anna, Cellbricks.
Yeah, hi, I'm Anna Kreuder from the startup Cellbricks. We are from the Technical University here in Berlin, and we developed a 3D bioprinting system with which we can print living tissue. And our background is that we come from a lab where we try to develop mini organs for drug testing. And the secret is somehow that you want to have the cells to behave just like in a normal organ. And it's common sense in research nowadays that if you have your cells in a 3D environment, they behave more physiological. And so this is where we're heading to. But so far, nowadays, it's quite difficult to reproducibly form like 3D cell aggregates. So we developed the printer with which we can reproducibly make 3D objects with cells inside. And they actually live and are functioning. And I brought you an example. So this is basically an example for a mini organ, just to show how highly defined we can print. This is without cells, but basically we could do the same thing with cells. And so then the cells are like in a 3D environment, and they can then interact with this environment and also like build their own surrounding, which is then even more physiological. And in the end, we can't just print mini organs for drug testing, but it's also possible that in the end you can print bigger tissues for transplantations or even whole organs.
Perfect that you say that. It was really, I think you maybe always dread this question, but how far are we away from really having organs that can be transplanted?
Yeah, so experts estimate that in about 20 years, there'll be the first 3D bioprinted organ. I think it's quite ambitious, but we see that like there's the proof that you can print cells in this manner and that it works.
Yeah. But can you take us through the process a bit? How does it work to really print an organ and let the cells fuse?
Right. So the first thing is that you have to think of a model, like how does your mini organ or should it look like? So you basically model in a normal CAD program your like 3D object, and you define materials. Like in this part are these kind of cells with this material, and this part it's something else. And then you just make a normal STL file, it's the standard format, and then you can transfer it to our printer system. We have an own software which translates this format to the printer itself. Then you have to introduce the materials, like the bio-inks, we call them, and you have to introduce also the cells with which you want to work. Then you press a button, and then the printer makes the 3D object with the materials as you defined. And in the end, you have like a mini organ like this, or a little tissue, which you then cultivate. This is basically the process.
But, okay, totally. But why does it take then 20 years to really print a real organ?
Yeah, so there are some more difficulties to it. So basically, when you just have a clump of cells,
Yeah.
this clump or this architecture can only reach a certain size until it's too big in order for nutrients and gases to perfuse to the inside cells. So basically, only the outer cells will survive. So it's crucial that you can introduce somehow nutrients, and this is not possible yet. With our printer technology, we can introduce very small vessels which can or which enable the supply of the cells even inside of a bigger construct of cells with nutrients. So this is basically like the kind of holy grail in the bioprinting area, that you need vasculature and you need it to be really precise. And current technologies are still working on that.
Really interesting case. Joachim, you also got a really interesting case with your light writer.
Yep.
We've seen it before in the background. Could you tell us a bit about the light writer and how you came up with the idea to produce a motorcycle that is 3D printed? Oh, there it is again.
Yeah, very good. So we have it on stage. So actually, the interesting thing about this, it's not really a motorcycle, but you see it already at the components we used. It's more from fat bike and downhill, but anyway, the frame itself is designed in a what we call entirely numerically driven way. So what does it mean? It means that you basically have to make sure that you can attach the wheels somehow. The weight of the driver should not exceed 150 kilogram, and then you have some various load cases regarding damage or failure load cases. So you crash in a car or somebody hits the bike from the side, and all these load cases we actually got from BMW, by the way. So the same load cases they use for typical motorcycles. And then you apply all those load cases to a so-called design space. So what is design space? It is actually the area where you want material in the end. Where you don't want material, this is non-design space. But everywhere else, it's just a full block of material. And then by the numerical optimization, you virtually machine away all the material where it's not necessary. So you only have material left in the areas where there is actually a force flow going through this whole setup. And this is then taken by an industrial designer and put into a nice looking design like this. So actually it's entirely numerically driven. You don't have to have any background on machining, on production technology, until the one who needs to produce it will have a look at it. And usually it's the designer, in our case it's engineers who have also an aesthetic feeling. Usually engineers are more very pragmatic guys, but we found some who even have an aesthetic feeling, and these are actually the best or well-suited guys to do this. So they make such a structure happen. And I mean, the light writer is just one example. Again, this armrest is another example where we entirely optimize a given product. So this is the product, and there are only 3 load cases, very simple load cases. I guess all of you have did flu from time to time or do fly from time to time. This is an armrest, so you usually sit in your seat, and there are 3 load cases. There is this load case you probably know yourself, where you actually you do a little bit of gymnastics when you stand up when the plane is landed. So it's a force from the top. Then usually, when the cabin attendants wants to give you something to drink, they usually hit from the side to this armrest. Maybe if they are too small to get to the overhead compartment, they step on it, so this is another load case. And probably if you, let's say, are not thin enough and you do rarely fit into your seat, you have a side load on this armrest. So these are actually the load cases. And this is the current design. This is the new design. It fulfills exactly the same load conditions, but is, as I said, 100 gram more lightweight, which is quite a lot for an airplane. And in total, I mean, you save yourself a few hundred tons in CO2 savings over the overall lifetime of an airplane. And I mean, these are just examples what you can achieve if you apply this completely different way of designing components and then printing them. I mean, unlike what we have here to print cakes or tissue, what we do is the so-called laser sintering process. So we have metal powder, and layer by layer with a laser, you just melt the areas where there is actually material. So a part like this, you would orient like that, and then layer by layer, you print multiple of them in, unfortunately, in 70 hours. So it takes really a few days, but not only for one, you print 20 or 30 in one shot.
But is that really, bionic design in general is not a new concept, right? Or is it? Because I was wondering, is 3D printing really enabling you to do this in that way, or could you also use injection molding or other techniques?
The thing is, these kind of things you can do by injection molding or die casting as well, as long as it does not get too thin. It gets really interesting if you do not only focus on weight reduction, if you focus on functional integration. So we have, for example, problems where you have a heat exchanger. So there is a kind of heat transfer involved in this component. The heat exchanger needs to operate at 700 degrees, for example. So you have a structural loading component as well. And last but not least, the whole flow throughout the component needs to be perfectly computationally optimized. So you have three physical disciplines in a combination. And then you usually end up with structures you can't manufacture in any other way. You can only do by 3D printing. And there, this new, inspired by nature or organic design absolutely makes sense.
Yeah. Daniel, coming to the good part in life, food. I was wondering, there are a lot of companies like Katjes and Barilla focusing on how to implement 3D printing into their business models. I don't have a 3D printer at home or a food printer, but I was wondering, what do you think about it? Will everyone in the future have a food printer at home? And maybe also what business models, B2C and B2B, will be possible? Or can you imagine?
Yeah, I think maybe you will have your own food printer at home in the future, but first of all, we have to, the people have to be skilled to do 3D modeling and stuff like that. But if you look at a computer 30 years ago, a few people were able to use a computer, and now just everyone does it. And 3D printing is growing very fast, and I think the skills will be there in the future. But just for my case, I think first would be a printer set up in a bakery or in a bistro where you can go and where you can order it, and they print it and just take it at home, or you order it online, and maybe in the future you have your machine at home.
Okay.
I have a question for you.
Yeah.
Sorry. So, did you always work with extrusion?
Yes.
With the extrusion system, or did you try anything else too before?
No, I just use an extruder. Yeah.
You have your printer in the exhibition area, right? In the Get Started area.
It's over there. And food printing today is always you put something in the cartridge and the same thing is coming out at the bottom.
Yeah.
So no, there's one. I think sugar is a little bit like powder printing. So sugar is printed with the powder layer and water, and that differs a little bit. But usually it's just extrusion. Yeah.
Okay.
And
I have a question. You know, the ingredients, is it like in a normal cake, or is it more
Yeah,
chemistry.
the DAO was really challenging to me.
Yeah.
First, I thought it's a hardware. You have to build a machine. You need a software, and yeah. Then I realized no, the DAO or the pastes I put in, I just not only printing cake. I've tried pasta and mashed potatoes and stuff like that, and the consistency is very important. But in the end, there's nothing in what you can't find in another cake. But yeah, there are some ingredients that there's a little bit more inside, and some are less. And yeah, the paste has in some way to be fluid enough to pass through the machine, but it has to be stable enough to stay in form in the baking tin at the same time. And yeah.
Okay.
You can't use a very sticky yeast dough. That won't work.
But
Do you
I
bake
was-
it afterwards?
I bake it afterwards, right? The process doesn't differ that much from conventional baking. I prepare the dough, fill it in the cartridges. The machine does only the arrangement in the baking tin. Afterwards, I bake it. And
So what will be your next steps for all three of you, for your startups, and what are you planning for the future? What are your next steps funding-wise, markets you want to tackle, or whatever?
I mean, for us, we really try to. We are in the phase of Series B now, and we really try to play the big game in Silicon Valley. We have various venture capital guys interested, because you know it's a multi-billion business, especially in the industrial additive manufacturing. And the way how we are currently positioned could allow us to really grow this business to the level where we expect to. So 200 people in the next 2 years, and I mean we are 17 today, so this will be really challenging in the end. But I mean that's the Silicon Valley game. Let's see how we can play it.
Daniel?
Yeah, so yeah, we're facing our first round of funding. We also get another Forschungstransfer too from the beginning of next year on. And yeah, we're soon going to publishing like actually a print without cells yet, but yeah.
Are you also
first
selling the
product.
printer? Yeah? Yeah, okay.
yeah, for me, I think first of all would be to build a faster and better machine, because it's still very slow. And next step would be to talk to DAO specialists, because it's the dough is very condensed. It's not that fluffy as you want the cake to be, maybe. And yeah, next step would be to sell cake.
What about investments? Barilla and Katja's coming to you and asking you to print their cakes?
Yeah, they didn't call me yet, so I'm waiting.
I would now like to open up for questions, if there are any. Probably so interesting startups here. Okay, not so interesting. Okay, then maybe one last question. You told it a bit, but not so much. You said you have a strong focus on design, and you also said design is important for food printing also in the future, and has been. You didn't tell because I didn't ask, but you all have a background in biology, medical technology, and biotechnology. I was wondering if that has anything to do with what you're doing today. I mean, for you for sure, but the other two, did your studies help you, your education, to I don't know, come into contact with CAD design, or what was it that brought you to your companies? Like,
actually, one of my modules was medicine technology, the other was production technology. So that's why whatever we do is mainly production technology driven. But the medicine technology thing is interesting, because in additive manufacturing, as I mentioned, we focus on medical applications as well, and so it's a good fit, because it's a lot of the implant materials did not change when I studied, so we can still use this knowledge today for not for tissue, but mainly for cranial implants, knee, hip implants out of titanium, for example. So that's what we also do. Yeah.
Daniel, a few last words.
Yeah, I studied biology, and I'm a virologist, and But basically, that has nothing to do with this. I know how to clean the stuff afterwards so that there is no bacteria growing, but in the end, no.
Okay, thank you very much. We're now at the end of our panel. I don't know if you be here around here and maybe answering some questions. If you were scared to ask questions in public, you can ask them now. Thank you very much.
Thank you.
And
Thank you.